So people discovered elements, and after a while there came to be a lot of different elements that scientists were aware of, and then it becomes a little challenging. Well, how do we organize these? What do we do with them? And so Dmitry Mendeleev was a Russian scientist who was interested in this, and he was trying to find a way to arrange the atoms. And he proposed ordering them in order of increasing relative mass. And he found that when he put them in a row by increasing atomic mass, that there were certain properties that recurred on a regular basis. It's a little bit like the keys on a piano, right? You've got C and D and E and F and G and A, and then it goes to A, B, and then C. The next C is an octave higher than the first C. It's not the same note, but it's very closely related. It's a harmonic of the first note. So this is a little bit like a piano keyboard, where here this might be C, and there's C again. And here's another one that acts very much like that. So he observed these recurring properties, and he arranged the elements so that those recurring properties lined up in columns. And this became known as the periodic law, that when you order the elements in this way, you get recurring properties. The properties recur periodically in a certain period. So here is a mostly complete enough periodic table. And there's a lot of information hiding in this periodic table. So this one is color-coded. The sort of beige area here, though all of these elements are metals. Up here in the upper right corner, those in the green, those are nonmetals. And then there's this stair-step line. It's not very evident on that periodic table on the wall, but if you look closely, it is there. This stair-step line divides the nonmetals from the metals, and along that line, a lot of these elements are called metalloids, or semi-metals. They have properties that are kind of in between, which is not unreasonable because they're falling in between the nonmetals and the metals in the periodic table. So if I ask you whether vanadium is a metal, a nonmetal, or a semi-metal, you should be able to look at the periodic table and tell me. So vanadium, okay, you might say, well, gosh, I don't know the symbol for vanadium. How do I find it? Well, use your best guess. Vanadium starts with a V. Maybe it's V for vanadium. Well, turns out it is. Vanadium's over here, so it's a metal. Selenium's up here. It means it's a nonmetal. Tellurium is a weird one right here, Te. That's a semi-metal or a metalloid. Okay? So we can identify what kind of an element it is by its position in the periodic table. Metals are on that left side. They have similar properties. These are common properties of metals. They conduct heat and electricity. You can pound them into flat sheets. You can draw them into wires. They are often shiny. Most importantly for chemistry is they tend to lose electrons when they undergo chemical changes. And there are some examples. The nonmetals are on the right side. Their properties are not as consistent as the metals. Some of them are solids at room temperature, others are gases. They are generally poor conductors. So the nonmetals are kind of the opposite of the metals, but not exactly. So metals are good conductors. Nonmetals tend to be poor conductors. They tend to gain electrons. So metals lose electrons. Nonmetals gain electrons when they undergo chemical changes. Then the metalloids are along that zigzag line. They have very mixed properties between. They're also called semiconductors. You've probably heard of semiconductors, the Silicon Valley here in California. Silicon is a semiconductor, and it's very important in making computer chips, right? Semiconductors are really useful because they have an intermediate electrical conductivity, and that electrical conductivity can be changed and controlled by what you do to the metal itself. So examples are silicon, arsenic, and germanium. So classify each of these elements as a metal, a nonmetal, or a metalloid. And here we're giving you the symbols so you don't even have to know the names. So S, what is it? It's a nonmetal. How about Cl, nonmetal? How about Ti? That's a metal. And Sb? Metalloid. Oh, that was a funny looking D. Okay. Sb is antimony. How do you get Sb out of that? Well, that comes from its old name. Let's go back to the periodic table here. So not all of the elements along this line that are touching that line are metalloids. All of them but aluminum and polonium. Now, polonium's an odd one we're probably not going to run into much, and I'm definitely not going to ask you, is polonium a metal or a nonmetal or a semi-metal? Aluminum, though, we should know is a metal, right? Aluminum is used as a construction material. The cookie sheets you have in your kitchen at home, the pots and pans, most of them are probably made out of aluminum. It's shiny, and we should recognize aluminum as a metal. So other than aluminum, all of the other elements touching that line that you're likely to be asked about are semi-metals or metalloids, okay? Oh, I could have used this one. There's more information hiding in here. So there are these yellow sections. This is the first two columns. They kind of stick up. And the last 6 columns that kind of stick up. These are called the main group elements. The main group elements have pretty predictable properties and undergo predictable reactions. These in the blue, it looks like there's something missing up here. These are the transition elements. The transition elements kind of bridge this gap from this part of the main group to the other part of the main group. It's a transition. Their properties are much less predictable. So each column in the periodic table is called a family or a group. Some of these groups have names. And you need to know these names. Group 1A, these are called the alkali metals. Hydrogen is over there. We're going to see that hydrogen is an exception to like everything. I think of him as the baby brother of the element family, that littlest child. They get to break all the rules, and people say, oh, isn't he cute, right? And you're thinking, man, if I had done that, I would have been hurting for days, right? Not fair. Anyway, hydrogen is not a metal, even though he's hanging out here with the metals. So sorry about that. But these are the alkali metals. The group 2A is called the alkaline earth metals. The rest of these guys don't have very important names. Group 7A, these are called the halogens, and group 8A are called the noble gases. You need to know the names of those columns. So these columns are numbered. This is 1A, 2A. The main group ones all have A's, 3, 4, 5, 6, 7, 8. There is another set of numbers for the groups or the families. Well, I don't have a periodic table that shows that right now. If you look at the periodic table up here, what's it got? Oh, it's got the good numbers. There's another set that just starts on the left and goes across 1, 2, 3, 4, 5, all the way to 18. I prefer these numbers with the letters, and those will always be present on a periodic table that you will have for an exam. So the alkali metals, we call this a family because these guys all share some common properties. The halogens, these are like, children in the same family. Are they identical, exactly the same in every respect? No. But do they share some common characteristics? Yes. So if you look at my children, it looks like they were made with a cookie cutter. Bang, 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 bang. Yeah, there's 6 of them. They look like they were made with a cookie cutter. And a lot of people who don't know them well can't tell them apart, except for the girl. They share similar physical characteristics, and they share common interests as well. So far, all the boys like playing tackle football. It's cool because I like watching them play. They have common characteristics. Are they all exactly the same? No, they have different personalities. They are their own people, but there's a commonalities between them. And so within this halogen family of elements, these elements do some things in a similar way. The noble gases have some things in common. Okay, any questions? I'm going to go through these slides really quickly because you could very easily read about this in your textbook. The group 1A metals, alkali metals, it's these guys, they're very reactive. In fact, they will react with water. This is a picture of what sodium does if you put it in water. Bursts into flame. Kind of fun and dangerous. The alkaline earth metals are also reactive, but not as reactive as the alkali metals. Here's what happens if you put calcium metal in water. It will fizz and react and generate hydrogen gas. The halogens, jumping over to the other end, are very reactive nonmetals. Chlorine gas, this is iodine. On the periodic table on the wall, you'll notice that most of the elements have their symbol in black, but some are red, and there's 2 that are in blue. The ones in blue are liquids at room temperature, mercury and bromine. At room temperature, about 25 degrees, those are liquids. The red ones are gases at room temperature. Okay? So iodine is a solid at room temperature. Chlorine's a gas at room temperature. The noble gases in group 8A are chemically inert. They undergo very, very few reactions. And that's why helium is really nice for filling party balloons, because if it gets too close to the birthday candles, the balloon will pop, but it won't explode. If you filled your balloons with hydrogen, they would also float very nicely, but there's this explosion hazard. Have you heard of the Hindenburg? Big dirigible full of hydrogen, and yeah, it blew up. We don't fill blimps with hydrogen anymore. We learned from history. Okay, so we should be able to answer questions like this. To which group or family of elements does each of these belong? So Li, that's an alkali metal. What is the number for that group? 1A. B, boron. It's a metalloid. It's right along that line. So it's a metalloid, but the group or family is what we're looking for. No, we're looking for either a name or a number. It doesn't have a name. It's group 3A. So this is part of group 3A. They all have numbers, only some of them have names. How about I? That's iodine. What group is that one in? It's a halogen. And it's in group, the group number is 7A. How about AR? It's a noble gas, and the group number is 8A. We're going to find out in the next week or so that the group number tells us a lot about the particular element. Any questions?
Yeah, you said that I is halogen?
I is a halogen. Mm-hmm.
I see it, iodine.
Yeah, so here's iodine. So the name of the element is iodine, but it's in the group named halogens.